As you watch this video, please follow along the notes on your note sheet. Ionic bonding involves the transfer of electrons. That means electrons are moving from one atom to another atom. Metals lose electrons and become cations. Cations are positively charged ions. Let's think about why this makes sense. If something loses an electron, it loses a negative charge. That's a negative charge. So if something started out with 10 protons and 10 electrons, and now it loses one of those electrons, loses one, so now it has 9 electrons. It now has 10 positive charges and 9 negative charges. So that's like 10, so that's like plus 10 and minus 9, which would equal a positive 1. There's one additional positive charge. There's one more positive charge than there is negative charge. So when something loses electrons, it now has a positive charge. It becomes a cation. Metals usually transfer 1 to 3 valence electrons to nonmetals during the ionic bonding process, as they have a low number of electrons in their valence shell. So when we look at this atom of sodium, this Bohr diagram of sodium, in the valence shell, there is only 1 valence electron. To become stable, sodium could either gain enough electrons to have 8, so that would mean it would have to gain 7 more. Okay, 7 more electrons in order to have a total of 8 on its valence shell, which would be a complete shell. Or it could just lose this 1 electron, and then this shell would become the valence shell. And notice that there are 1, 2, 3, 4, 5, 6, 7, 8 valence electrons once this electron is lost. So now sodium would be stable. So sodium would lose 1 electron, would transfer 1 electron. It would give this 1 electron to a nonmetal. Similarly, magnesium would lose its 2 valence electrons, and aluminum would lose 3 valence electrons. So the Bohr models of sodium, magnesium, and aluminum are shown above right here, each with 3 energy levels. And remember, energy levels are the shells. If these atoms lose their valence electrons, they each would be left with 2 energy levels, these 2 energy levels, and the valence shell would be this shell now, and so there would be 8 valence electrons. So now we need to determine the charges. What would the charges be? Well, sodium has a charge. Sodium has 11 protons. Sodium has 11 protons, and now it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. It lost 1 electron, so it has 10 electrons. So it has 11 positives and 10 negatives. So that means it has 1 more positive than negative. So it would be a positive 1 charge. So its charge is plus 1. Magnesium lost 2 electrons. It has 12 protons. It now has 10 electrons because it lost 2 electrons. So 12 minus 2 gives us 10. And then the 12 positive charges and the 10 negative charges means that it has a positive 2 charge. It has 2 more positive charges, 2 more protons than it does electrons. So that would be a positive 2 charge. And so aluminum would have a positive 3 charge because it loses 3 negative charges. So now it has 3 more positive charges than negative charges. Nonmetals function the opposite way. Nonmetals gain electrons and become anions. Those are ions with negative charges. Why a negative charge? Because it's gaining additional electrons. So now it has more negatively charged electrons than it does protons, so the whole thing is negatively charged. Nonmetals will gain between 1 and 4 valence electrons from metals during the ionic bonding process, as they already have a high number of electrons in their valence shell. I'm going to complete the Bohr model for nitrogen, and then you are going to complete the Bohr model for fluorine. So nitrogen, looking at my periodic table, the atomic number is 7. The atomic mass is 14, so it has generally 7 neutrons. There can be 2 electrons on that first shell, and there's a total of 7 electrons for a nitrogen atom. We are not drawing ions right now. We are drawing atoms, which are neutral. So for atoms, protons equal electrons. So there are 7 electrons, just like there's 7 protons. So we have 2 on the first shell, and then 5 on the second shell. So this is nitrogen. Go ahead and pause the video and draw the Bohr model for fluorine. As you can see in the 2 examples above, the valence shell of the nonmetal, of each of these nonmetals, is almost full. Therefore, right, they could either lose 5, it would have to lose the entire valence shell, so these atoms would have to lose all of their valence electrons, or this atom of nitrogen could gain 1, 2, 3. So 3 is lower than 5, so they gain electrons. Let's practice what you have learned by using electron dot diagrams to illustrate ionic bonding. Start simple by illustrating an ionic bond between sodium and chlorine to form sodium chloride. The symbol of the metal always goes first. Sodium, Na, is a metal, and therefore it will lose electrons. How do we know it's a metal? Well, if you look at your periodic table, looks something like this. Notice there is a staircase we should have drawn right across this section. And here's hydrogen. And so everything on this side of the staircase is a nonmetal, as is hydrogen. Everything else, every other element, including the ones down here, all of these are metals. So sodium is located right about here on your periodic table, therefore it is a metal. And therefore it loses electrons. Notice it also only has 1 valence electron, so it's going to lose that electron. Chlorine, on the other hand, is right over here and is a nonmetal, so it will gain electrons. Notice chlorine has 7 valence electrons, so it's very, very close to having a full outer shell, so it needs to gain 1 more electron to have that full outer shell. So sodium becomes positively charged, and chlorine, now called chloride, whenever a nonmetal becomes an ion, you add IDE to the end of it, is negatively charged because of the transfer of electrons. So what happens is sodium gives its electron to chlorine. So now chlorine has 8 valence electrons, and sodium has lost its valence electron. The opposite charges attract one another. So if sodium lost its negative electron, it is now positively charged. And since chlorine gained an electron, it is now negatively charged. And so this attraction is what forms ionic bonds. This attraction between the positive and the negative charge, that forms the ionic bond. However, ionic bonds are electrically neutral. So I want you to notice that if we have a positive 1 and a negative 1, we have no charge. The charges totally cancel out. We don't have more positive charges, and we don't have no more negative charges. They are 100% equal, so they are electrically neutral. When sodium loses its 1 valence electron, I want you to fill in these blanks on your own. So go ahead and pause the video and complete that box. Okay, so let's do one more. Use the dot diagram to illustrate the formation of an ionic bond between magnesium and fluorine. So first we need to figure out what is our metal and what is our nonmetal. Well, magnesium is right over here and fluorine is right over here. So magnesium is going to be the metal and fluorine is going to be the nonmetal. Again, metals will lose electrons and nonmetals gain electrons. So magnesium is in this group right here and has 2 valence electrons. And fluorine, which is in this group, the same group as chlorine, has 7 valence electrons. So what's going to happen? Magnesium loses its electrons, so it's going to lose this electron, give it to fluorine. Now fluorine has 8. Now this fluoride ion, which has 8 valence electrons, is stable. It can't gain this extra electron. Its outer shell is completely full. Therefore, we need to add another fluorine atom. And this fluorine atom also has 7 valence electrons. So this fluorine atom also wants to gain 1 electron. So it will gain the other electron from magnesium. Therefore, the chemical formula for this is Mg, the metal first, F2, there are 2 fluorines and 1 magnesium. And this is called magnesium fluoride. Notice the "ide" at the end.